Ever wondered how engineers stopped the Leaning Tower of Pisa from toppling over? It's one of the world's most famous architectural mysteries, and the answer is even more fascinating than you might think. Spoiler, no, it didn't involve straightening it with a giant rolling pin or a superhero's mighty push. The real solution was much more subtle and a lot more scientific. Alternate opening. If your favorite tower leans like it's about to nap, you might be in Pisa. The Leaning Tower isn't just a quirky tourist attraction, it's a symbol of resilience, creativity, and the power of human ingenuity. If it's still standing, after 850 years thanks to some very clever engineers, their work turned a near disaster into a global icon, and their story is as remarkable as the tower itself. Let's dig into how they pulled it off. The answer lies beneath your feet, literally in the ground below Pisa. The Leaning Tower of Pisa is a marvel of medieval architecture, but its famous tilt started almost as soon as construction began in the 12th century. The culprit? The soft, squishy clay soil beneath the tower couldn't handle the immense weight of all that marble and stone. First, the basics. Pisa's famous tower has been tilting almost since day one, thanks to squishy clay soil under its massive weight. The ground beneath the tower is a mix of sand, clay, and shells, which shifts and compresses unevenly under pressure. This meant that as the tower grew taller, it started to lean more and more, like a sleepy giant nodding off. By 1990, the lean reached a nerve-wracking 5.5 degrees, and everyone worried it'd fall over for good. The tower was closed to the public, and the world watched anxiously as experts scrambled to find a solution. The risk wasn't just theoretical. Engineers calculated that the tower could collapse at any moment, especially if a strong storm or earthquake hit the region. Teams of engineers, geologists, and historians from around the world gathered in Pisa, determined to save the iconic structure. They knew that any mistake could mean the end of the tower, and a huge loss for world heritage. So what did the experts do? They had to get creative, because the usual fixes for leaning buildings, like pouring concrete or adding heavy supports, could have made things worse, not better. Well, after trying some wild ideas, think electric currents to solidify the soil, mega anchors drilled deep into the ground, and even freezing the earth, they landed on something genius: under excavation. This method was both simple and brilliant, and it had never been tried on such a scale before. Sounds fancy, but it's basically like scooping a little dirt out from under the high side of a wobbly table so it settles back. Imagine you're at a cafe, and your table rocks every time you set down your coffee. Instead of shoving napkins under the short leg, you carefully remove a bit of material from under the tall one, letting gravity do the rest. The engineers approached the problem with extreme caution. They used small drill rigs to bore 41 tiny holes under the north side, the side that was higher off the ground. Through these holes, they slowly and carefully removed soil just a bit at a time, monitoring the tower's movement every step of the way. Engineers carefully drilled 41 tiny holes under the north side and slowly removed soil just a bit at a time. This process required patience, precision, and nerves of steel. Even the smallest miscalculation could have sent the tower tumbling. Over a year, they took out 70 tons of earth. No sudden moves. Every handful of soil was weighed, measured, and recorded. The team worked in shifts around the clock, making sure the tower's movement was slow and steady, never more than a millimeter or two per day. As the ground shifted, gravity gently nudged the tower upright, reducing its tilt by half a degree. It might not sound like much, but that tiny adjustment was enough to stabilize the entire structure and buy it centuries of new life. But the engineers didn't stop there. They knew that the tower's safety depended on more than just a one-time fix. They needed to make sure it would stay stable for generations to come. But it didn't stop there. To ensure the tower's safety, they ran countless simulations, tested their methods on scale models, and even built a full-size practice slab to rehearse the soil removal technique. Every step was double-checked and peer-reviewed by experts from around the world. To keep things safe, they tested these moves on a practice slab, set up giant weights as counterbalances, and even had cables ready to pull the tower upright if things got dicey. The counterweights acted like a safety net, and the cables were a last resort backup in case the tower started to move too quickly. Thanks to all this careful planning and teamwork, the Leaning Tower of Pisa is now stable for at least another 200 years. Tourists can safely climb its spiral staircase and snap those classic holding up the tower photos without fear. Today, the Leaning Tower still leans, just not enough to topple. Its tilt is now about 4 degrees, which is enough to keep its unique charm, but not enough to threaten its survival. It's a brilliant mix of ancient craftsmanship and modern engineering, proving that sometimes the best fix is the gentlest nudge. The tower stands as a testament to both the builders of the past and the problem solvers of today. So next time you see Pisa's famous tilt, remember it's not just a lucky accident, it's a marvel of engineering smarts, teamwork and a little bit of clay magic beneath the surface. The Leaning Tower of Pisa is proof that with patience, creativity and a willingness to try the unexpected, even the world's most precarious problems can be solved.